we are talking about the sex hormones, we are considering three kinds of such hormones, namely the estrogens, the androgens, and the gestagens. These are the three: estrogens, androgens, and gestagens. Okay. As for estrogens, okay, when we are talking about estrogens, we distinguish estrogen agonists, estrogen antagonists, and selective estrogen receptor modulators.
Estrogen receptor
modulators.
Okay. I write it.
Yeah? Okay. So when we are talking about estrogens.
Oh, not O-A?
Yeah, it's estrogens. I mean the English. Okay? Estrogen agonists, antagonists, and receptor modulators. Okay? No, here are the skeletons. We are already familiar with cholesterol, the 5-alpha cholesterol we were talking about last class.
Cholesterol or cholesterol?
Cholesterol, yeah. 5-alpha cholesterol. Okay, 5-alpha cholesterol, and this is the stereo representation, three-dimensional representation of the 5-alpha hydrogen. This is the 5-alpha hydrogen, opposite side to the 10-methyl group, you remember? Okay? This is the beta. The beta is the same side, and when we are talking about the beta series, we see the junction of the A and B ring is cis, and the cis junction means that the shape is not as planar as it was in the case of the trans. However, such a, I don't know perfectly what is the perfect description of this shape. No, that's another story. I just thinking about the shape of these two rings. You see, in the case when we are talking about cis fusion, cis ring fusion, the two rings form almost a 90-degree shape like this. However, we are talking about the transfusion. The transfusion is rather planar. You see, this is the trans. You see, A and B trans. Okay, and when you see this picture in 2 dimensions, you mean this is the real shape in 3 dimensions. Okay, this is trans. However, when this is cis, okay, this is the real shape, and the two shapes are very much different concerning the A and B rings. You see, like this one and this one. No, estrogens. Those compounds whose biological action resembles the natural female sex hormone, which is estradiol. Estradiol is the most of the natural estrogen with the most pronounced biological action. Okay? When you talking about estrogens in a narrower definition, okay? So there are 2 different definitions of estrogens. Okay? All of the compounds whose biological action is very much the same as estradiol. This is a fairly wide definition. Okay? However, there is a narrower definition which states that estrogens are only those compounds which are synthesized in the body. Okay? And those are the estrone, the estradiol, and the estradiol. Estradiol. Estrone, estradiol, and estriol.
Estriol.
Estriol. Okay? Triol means 3-hydroxyl. Okay? Diol means 2-hydroxyl. Estron has got only 1-hydroxyl. I will show that. Okay? Now here is the synthesis. You might remember the synthesis of the mineralocorticosteroids we were talking about last week. And in the synthesis of mineralocorticosteroids, dehydroepiandrosterone is a key steroid. Bless you. So if we start from dehydroepiandrosterone, okay, dehydroepiandrosterone, okay, which is this stuff, okay. The first step in this line is the oxidation of dehydroepiandrosterone.
Aldosterone or aldosterone?
Just a minute. How to say shift F5? The control F5. No.
Press one click.
This one. This one.
This one. Okay. No, dehydroepiandrosterone. Androsterone. Androsterone. Okay. Androgen means male. Male. Okay. Androgen. Yeah, it's a Latin word. Androsterone is the male hormone. Okay. And the oxidation of dehydroepiandrosterone results in androstenedione. Androstenedione. D1, yeah, you see, since D1. And androstenedione, okay, is converted into testosterone. Testosterone is synthesized in the testes. Okay? You see, androstenedione, testosterone, reduction of this is carbon 17. Okay? So reduction of carbon 17, carbonyl to hydroxyl to beta hydroxyl, okay, which is very important, results in formation of testosterone. Okay? No, and testosterone has got hormonal activity. However, the most important and the most effective hormone, male hormone, is 5-alpha dehydrotestosterone.
Active or inactive?
That's an active metabolite of testosterone.
Active.
Yeah. So this one, you see what is the difference? Here is a double bond, and this double bond is reduced. And this one is the 5-alpha hydrogen, and that's why this is 5-alpha dehydrotestosterone.
Why alpha?
Since this hydrogen is alpha, the entering hydrogen is in alpha position. Alpha is opposite to the material. Okay. What is the shape of this compound? AB ring. Trans. Trans means like this.
یکیش بالاست یکیش پایینه.
Haven't you heard about?
بعد تو پرتقالی تو سرم.
Haven't you heard about 5-alpha reductase? 5-alpha reductase.
Where?
In any.
Reductase is reductase.
Yeah, reductase. The enzyme 5-alpha reductase. That's the Greek name, abbreviated name. Catalyzes this conversion.
To the liver or some
Yeah, I mean this is synthesized in the testes. Okay, it gets into the circulation, and this enzyme expressed in several places all over the body, among others the liver. However, it's considered that the male baldness, there are some male
Badness.
baldness,
Don't hair.
don't hair,
Yeah.
is due to the very active 5-alpha reductase activity in the scalp.
Really?
Yes. So there are several reasons, of course. This is one of the possible reasons. And that's why, for example, there are some treatments that are used to inhibit this enzyme on the scalp. And sometimes it prevents development of baldness. Okay? However, if you stop the treatment, the activity of the enzyme is regained, and the killing of the hair shafts continues. No, so this is one of the ways. Okay, this is the way 5-alpha dehydrotestosterone is formed. Androstenedione, okay, is the precursor of the female hormone as well, estrogen. Okay, estrogen has got aromatic A ring. You see? Estrogen has got aromatic A ring. The enzyme which catalyzes this conversion of androstenedione into estrogen is called aromatase. Since this enzyme converts androstenedione into an aromatic derivative, that's why this is an aromatase. And estrogen is reduced to estradiol. You mean this one? I'm sorry, this is a hydroxyl here. Estradiol means 2 hydroxyl groups. This one, which is formed by reduction, estradiol, and this one, this is phenolic, OH. Sorry, this is mistake. Okay? So here we have an alcoholic, here is a phenolic. Estrogen is only phenol. And when we are talking about estradiol, okay, estradiol has got 1 more hydroxyl group in position 16.
Why do you say to the keto?
No, this is mistake. This is an OH.
OH and
Yeah.
other part?
Yeah. So estradiol conversion means reduction of the carbon 17 carbonyl to carbon 17 hydroxyl. Okay? No. So this is the synthesis. So dehydroepiandrosterone. Dehydroepiandrosterone. Is okay? Very good. No. Let's see steroid estrogen agonist. The first one. Estrogen agonist. Estrogen agonist with steroid skeleton. Okay? One of the oldest derivatives is actinyl estradiol. Actinyl estradiol is nothing else that substituted estradiol, okay, in position 17. An actinyl group is introduced, okay, to this. As for the synthesis, here we have, this is calcium salts of acetylene. This is the calcium salt.
Calcium or potassium?
Potassium salt of acetylene. You should use ammonia. Okay. This is, you see, this is a polar carbon-oxygen double bond. Yeah, okay. Here we have a partially positive charge. Okay. And this one is ionic. So, I mean, this bond is ionic. So this is a salt. potassium acetylene.
Yeah.
Acetylene, hydrogens are acidic. Did you remember? You studied it from organic chemistry. So,
Potassium easily depart.
yes, easily depart. Here is the carbon atom with negative charge, and this is added into this carbon, and afterwards the phenolate protonates. Gets a proton from the solvent.
Now that can be chiral, yeah? In use and yeah.
Oh, actually, yeah, of course. This way, the carbon 17 becomes chiral, but it's important that in case of ethinyl estradiol, the orientation of the hydroxyl formed should be very much the same as it is in estradiol, this beta, as the natural hormone. Okay? No, ethinyl estradiol is a estrogen, can be used orally. And there are several estrogens, you will see, and androgens. And if you have a look at the structure of the compounds, okay, and you can see any substituent next to the OH at carbon 17, okay, you can be sure that that steroid derivative can be used orally. You can ask why. Because this is the conversion, you see, this is a reversible conversion, and there is a natural equilibrium between estrone and estradiol. However, the hormonal activity of estradiol is much higher than that of estrone. Much higher. Estradiol's activity is much higher than estrone. So, however, if you introduce a substituent next to the hydroxyl, the enzyme cannot oxidize this hydroxyl back to carbonyl any longer. Okay? So it means you prevent the active form, the carbon 17 hydroxyl, okay, by means of introduction of a group, typically an alkyl, alkene, or alkyne group at 17, and this way you can keep the active form, the active estradiol form of the hormone, which is the most active derivative. Okay? No, there is a mestranol. Mestranol is the 3, it is 1, 2, 3, okay? 3-O-methyl derivative of estradiol, okay, of ethinyl estradiol. This is a propharmacon. What is a propharmacon?
Active
Drug.
metabolic with
Yeah. So if you introduce here a methyl group, okay, this methyl group can be eliminated by means of cytochrome P450 oxidation, and this way the propharmacon mestranol is converted into ethinyl estradiol. No, this is ethinyl estradiol mentioned in the pharmacopoeia. The identification of them described is infrared spectroscopy, comparison with the standard, and thin layer chromatography, again, comparison with the standard. And as for the assay, you should dissolve ethinyl estradiol in tetrahydrofuran as an organic solvent, add silver nitrate, Silver nitrate reacts with the actinyl group, okay, of the compound, I mean with this hydrogen, which is acidic.
Yes.
Okay? Okay? And silver ion, okay, forms a complex or salt-like compound with this actinyl unit, and equivalent amount of hydrogen ion is liberated. You see? And you can titrate the the hydrogen ion which liberated by means of sodium hydroxide. Okay?
Okay.
That's it. Not here is the
IR.
IR of estron, here is the phenolic OH, the CH2, CH3, again, you see, this is very typical of all steroids.
Yeah.
Since the CH2, the CH bonds are not very polar, that's why if there are only a few CH bonds in the compound, you cannot see such intense CH bonds. And here are the carbonyl. The carbonyl is very polar, that's why it's very intense. And here are the typical 1, 2, 3, 4, bonds for the aromatic ring. Okay? So that's briefly this is about the infrared. No, second group, subgroup, non-steroid estrogen agonists. Okay, since when we are talking about estrogen agonists,
We are talking about the estrogen, no.
agonists, we can steroids and non-steroids. There are two groups. Okay? And now we are talking about the non-steroid agonists. Okay? No, the non-steroid agonists typically, as for here, we frequently found esters of estradiol, benzoate, estradiol, propionate, these are steroids, of course, okay, which are propharmacons, of course, and typically they use in intramuscular injections, okay, and this way the prolonged action can be created. There are several other technological solutions how to introduce a drug into the body, and from which solution the drug is slowly